Hey guys, so I just made this entire video and somehow it got deleted. Yay, that makes me so excited. So we're not going to dwell on what happened. We are going to rock and roll. So I want you to stand up, push in your chair, and we're going to do some jumping jacks counting by some fractions. So we are going to count by sixths. So Miss Hoag's example, I do a jumping jacks, well, I say 1/6. When I say go, we will begin, and we're going to go to 12 sixths. Ready? Go. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. Stop. Everybody sit back down. So I am going to give you about 5 minutes to try to solve these on your own. Guest teacher, if you don't mind, go ahead and pause the video. Guys, I want you to think of some strategies you could use to figure out what these missing numbers might be. We're going to discuss what strategies you used here in just a second. So, go ahead and pause the video. I saw some hard work going on. So, for A, blank plus 2/6 equals 1 1/6. What do we know about 1 whole? Can we change a whole number into a fraction? Absolutely we can. What is 1 whole changed to a fraction with 6 in the denominator? Tell me 1, 2, 3. It is 6/6. So 6/6 plus the 1/6 we already had gives us how many sixths, friends? It gives us, tell me, 7/6. So we need to figure out how to get from 2 to 7. If you haven't done this already, make sure you're writing this down with me. If you know how to get from 2/6 to 7/6, raise your hand. Oh, I see those raised hands. 2/6 plus what equals 7/6? I want you to tell me when I count to 3. 1, 2, 3. Oh, yeah. 5/6. So, when I look at number 2, this question right here, the first step that I took to find my answer was to change 1 1/6 to an improper fraction. Alright, let's look at B. 2 4/5 plus blank equals 7 1/5. On B, 2 4/5 is 1/5 away from being 3. If I add 3 plus a number to get 7, what number would I need, friends? So 3 plus blank equals 7. Tell me what's going to be in the blank when I count to 3. 1, 2, 3. Absolutely. So our whole number is going to be 4. And we see that there is 1/5 in our answer, and we borrowed 1/5. So, if we put the 1/5 and 1/5 together, we get 2/5. Our first step for this problem was to change 2 4/5 to 3 wholes. That was our first step. C. 3 minus 2 1/3. Is there a whole number and a whole number? Can we take 3 and subtract 2 and get an answer? If we can, give me a thumbs up. When I count to 3, I want you to whisper the answer to 3 minus 2. 1, 2, 3. 3 minus 2 is 1. Good job, friends. And we have 1/3 left over. So what was our first step? Well, our first step was to subtract the whole numbers. And our last but not least is D. 4 and 1/12 minus 2 and 5/12. Yesterday, we talked about decomposing our numbers, and Miss Hogue is going to let this draw a rectangle for her, because her rectangle looks awful. There we go. And we'll even let it draw a line for us. Absolutely. Perfect. It's a little not straight. That'll be alright. So, on our first number, we have 4 and 1/12. Our second number, we have 2 and 5/12. When we look at our first number and our second number, could we easily take 2 from 4? Absolutely. Now let's look at our fractions. Could we easily take 5/12 from 1/12? Not without having to decompose. So let's go ahead and let's decompose our 4 into 3. Oops, and I want to do that in pink, not in green. So decompose our 4 into 3 and a fraction. Well, 3 plus what fraction would equal 4 wholes? 3 plus 12/12. And we already had 1/12. So let's put together what we can for our first number. Woo, ziggly squiggly. 3 plus, what's 12/12 plus 1/12? Tell me. 13/12. Absolutely. So for our first number, we have 3, and we have 13/12. Let's look at our second number. Is there anything we're going to have to decompose with our second number? No. So guest teacher, if you don't mind, will you pause this video and give the students an opportunity to solve this, like, say a minute? Glad you're back. When you solve this, when I count to 3, I want you to tell me what you put for 3 minus 2. 1, 2, 3. 1 is correct. And let's do 13/12 minus 5/12. I remember I'm counting to 3. 1, 2, 3. If you said 8/12, you are correct. So, let's look at our first step. Our first step was to decompose 4 into 3 and 12/12. So guest teacher, if you don't mind, will you pause on the screen and give students an opportunity to get these written down if they do not have them already? Whenever they are done, you can go on. we are going to be moving on to decompose or not to decompose. So, sometimes when we have a problem with fractions, it is going to be important for us to decompose a number so it's simpler for us to solve. Sometimes we can just add or subtract like normal. Here's some addition and subtraction expressions. Sort them into two groups based on whether you think it would be helpful to decompose a number to find the value of the expression. Be prepared to explain your reasoning. So you are going to work for about 5 minutes with the people at your table to sort A through J into not necessary or not helpful to decompose, or it is necessary or you have to do that. You have to decompose one or more of the numbers to help solve. So you've got about 5 minutes, and I want you, after you finish, to independently solve one of the problems from the first column where it's not necessary to decompose, and one of the problems from the second column where it is necessary to decompose. I saw y'all working super hard. Good discussions, guys. So, check with Miss Hogue. It is not necessary to decompose A. You can subtract 18 minus 7. It is not necessary to decompose B. You can add 1 plus 9. Let's see. It's also not necessary to decompose E, not 3E, or I. So that means all of the rest of these letters, it is going to be necessary to decompose one or more of the numbers. So C, D, F, G, H, and J all need to be decomposed before you're able to completely solve those. So, number 2 says, choose at least one expression from each group and find their values. I'm going to choose A, 18 fifths minus 7 fifths. Eighteen minus 7 is 11. That is correct. And then our denominator stays the same. For my second choice, or the necessary to decompose, I'm going to choose C because Miss Hogue noticed a mistake that she made up here. And so Miss Hogue is going to fix her mistake. Isn't it crazy that teachers can make mistakes too? What? Especially sick teachers. So, 7 minus 1 3/8. So, I need to change my whole numbers into fractions. So, 1 is equivalent to 8/8. So instead of just having 1 3/8, I have 11/8. So now I'm left with 7 minus 11/8. But guys, is that super simple to solve? No. So I need to do some math to figure out what 7 is going to be. Remember last week we talked about taking our whole numbers and changing them into fractions. So let's do that right now. 1 whole is equivalent to 8/8. So let's count by 8s. Ready? 8, 16, 24, 32, 40, 48, 56. So, 7 is equivalent to 56/8. 4/8. In my next